Ever wondered how the world's most advanced fighter jets are actually made? These aren't just planes, they're high-speed, stealth-powered supercomputers that fly. But behind every supersonic engine and radar-evading surface is a secretive, high-tech process few people ever get to see. In this video, we're taking you deep inside the factories, the tests, and the engineering that brings fighter jets to life. Stick around. What you'll see will change the way you look at the skies forever. Born for battle more than 100 years ago, fighter jets didn't even exist. In World War I, aircraft were simple machines, wooden frames covered in canvas, barely powerful enough to stay in the air. But they changed the battlefield forever. From these humble beginnings came the spark that ignited the future of air combat. As decades passed, planes evolved fast. Propellers gave way to jet propulsion, and speed limits shattered as new designs hit supersonic velocity. By the 1970s and 80s, fourth-generation jets like the F-16 and F-A-18 were rewriting the rules of dogfighting, integrating radar and missiles with the agility of modern engines. But in today's world, speed isn't enough. A fighter jet must see first, shoot first, and disappear after. That's why we entered the era of the fifth-generation multi-role fighter. These jets don't just fly, they think. They're stealthy, connected, and smart. At the center of this revolution is the F-35 Lightning II. Designed to combine stealth, precision strike, and battlefield awareness, the F-35 is not just one plane. It's a family of fighters built to dominate air, land, and sea. As Lockheed Martin puts it, it's not just a jet, it's a flying supercomputer. From silent radar profiles to vertical takeoffs and real-time data sharing, the F-35 isn't about flash, it's about control. Air superiority today doesn't belong to whoever flies fastest. It belongs to whoever flies smarter. Now that we understand why these jets are so advanced, let's break down how one is actually created, starting with the blueprint. Blueprint to reality. Before a single bolt is turned or panel is welded, it all starts with a design, a vision turned into science. Creating a fighter jet like the F-35 means designing every angle, every surface, and every system for one goal: dominance in any combat scenario. The jet's shape alone tells part of the story. Smooth curves, angled surfaces, and internal weapons bays are all built to scatter radar signals. Engineers call it stealth shaping. What makes the F-35 nearly invisible to enemy radars? But stealth is just the beginning. Inside, it's built with composite materials that are lighter, stronger, and more heat-resistant than metal. Every inch matters. Every gram shaved adds range, speed, or payload. It's not just about flying, it's about surviving, said a lead systems architect. Then comes the software, arguably more important than the hardware. With millions of lines of code, the F-35's brain powers its radar, targeting, and flight control systems. These systems even simulate enemy threats and suggest real-time responses. It's like having a co-pilot that sees through walls. This jet wasn't built by one country alone. The US leads the program, but partners like the UK, Japan, and Italy shape the specs. That's why it's called a joint strike fighter, because it's designed to serve many missions for many nations. But designing is only half the story. The real magic happens when those designs are brought to life inside some of the world's most advanced aircraft factories. The factories that build them. Building a fifth-generation fighter jet doesn't happen in one place. It's not like assembling a car in a single warehouse. This is global collaboration on a microscopic level, where each bolt, wire, and panel comes together from different parts of the world, each with its own layer of secrecy, precision, and responsibility. At the center of it all is Lockheed Martin, the primary contractor. But they don't go it alone. This jet is the result of a partnership involving Northrop Grumman, BAE Systems, and dozens of other companies across allied nations. Each one handles different components of the jet, and the process is engineered to be both modular and highly secure. For example, the center fuselage, the structural spine of the aircraft, is manufactured at Northrop Grumman's Integrated Assembly Line, IAL, in Palmdale, California. This is not your typical aerospace factory. It's a clean, quiet environment where robots, Lasers and humans work side by side in an ultra-orchestrated ballet of precision manufacturing. At the IAL, you'll find some of the most advanced robotic work cells in the industry. These robotic arms aren't just programmed to move parts. They scan each component in real time, detect variances, and adjust automatically. Surrounding them are laser-guided measurement systems, ensuring every fastener and panel aligns within fractions of a millimeter. What's truly groundbreaking is the use of projection works, a technology that projects digital instructions directly onto the aircraft's surface. Instead of flipping through blueprints or screens, assembly techs see exactly where each part should go, projected in real time, in 3D on the actual airframe. We don't just build aircraft, we build trust, says a production manager at the IAL. And that means getting it right before the pilot ever steps into the cockpit. Security here is more than just ID badges and locked doors. Every workstation is air-gapped from outside networks. Every employee has clearance levels. Even tools are tagged and scanned, ensuring nothing is out of place or left behind inside the jet. Meanwhile, over in the UK, BAE Systems constructs the rear fuselage and empennage, essentially the jet's tail section. In Italy, Leonardo handles wing manufacturing. These components are shipped using specially designed aircraft like the Lockheed Super Galaxy or Airbus Beluga, built to carry full-size fuselage sections thousands of miles across the globe. All these parts, thousands of them, arrive at Lockheed's final assembly and checkout, FACO facility in Fort Worth, Texas. Here they are finally joined, tested, and transformed into combat-ready aircraft. It's a complex system, but one that works flawlessly because it has to. Every F-35 is more than just a jet. It's a technological alliance, wrapped in composite skin and engineered for the skies. Now that the factory network has delivered the core components, it's time to build the jet's central frame, the skeleton that holds it all together, the fuselage. Let's take a closer look. Building the fuselage. At the heart of the F-35 is its center fuselage, and building it is a masterpiece of precision. That job belongs to Northrop Grumman. Their facility uses a powerful blend of robotics and human craftsmanship, all to make sure every component is exactly where it needs to be, down to the tiniest fastener. It all starts with projection works, a system that literally projects laser outlines onto the fuselage, telling technicians where to drill, place, and install every part. It's like assembling a 3D puzzle with glowing instructions. One mistake can throw off the radar signature, a senior technician explained. That's how tight the margins are. Over 3,000 fasteners and 10,000 wiring points go into just one section. Each one must be accurate to within fractions of a millimeter. Why? Because if there's even a small gap in a panel or a misaligned seal, the jet can lose its stealth advantage. Lasers measure everything. Sensors track torque, pressure, and material stress. It's not just about assembly, it's about perfection. But a jet doesn't fly on a skeleton. Now that we've built the core, it's time to give it wings. Wings, stabilizers, and tail. Wings do more than lift a jet into the air. They shape how it moves, how it maneuvers, and even how it hides. That's why F-35 wings and tail structures are made using composite materials. They're lighter than aluminum, but tough enough to handle supersonic stress. These components are built separately, wings in Italy, stabilizers in the US, and other parts across the globe. Once they arrive at final assembly, technicians use laser alignment tools to fit each one with perfect balance. Even slight misalignment would affect handling and fuel use. Every wing is custom fitted to its fuselage. It's like matching a high-performance sports car's suspension to its frame. Only here it has to function in the most extreme environments on Earth. Wings aren't just bolted on, one engineer noted. They're blended. The jet becomes one seamless flying body. The stabilizers and tails are added next, completing the aerodynamic structure. From here, the jet starts to look and move like it's ready to fly. But there's one thing still missing: power, the power within. Now that the wings and frame are complete, it's time to give the fighter jet its heart, the engine. And not just any engine. The Pratt & Whitney F-135, a beast of engineering capable of pushing this machine past the sound barrier, and straight into combat. This engine isn't just powerful, it's smart, efficient, and adaptable. With up to 43,000 pounds of thrust, it can launch the F-35 off a carrier deck, sustain supersonic flight, or even hover in place, depending on the model. The F-35B, for example, features an ingenious addition: a lift fan installed vertically behind the cockpit. When the pilot needs to take off or land in tight spaces, like on a ship or a remote battlefield, the engine works in tandem with a rotating rear nozzle, and this lift fan to create vertical thrust. "It's like flying a fighter jet and a helicopter all at once," said one Marine Corps pilot. Installing the engine is a delicate operation. It's not dropped in like a car motor. It's suspended, guided by lasers, and seated into place with tolerances tighter than a millimeter. Mounts must absorb shock, but still keep the engine rock solid during violent maneuvers. Then come the checks. Technicians run simulations to detect vibration, inspect the flame path, and test heat shielding. The entire afterburner system is pressure checked. If anything's off, the engine doesn't move forward. "This engine breathes fire," said one engineer, "but it has to do it in a whisper." Once installed, it's time to move from raw power to raw intelligence. Brains of the beast. While the engine makes the jet fly, the avionics make it fight and think. Inside the F-35 are layers of sensors, radar, targeting systems, and flight computers, all working in perfect sync. At the center is the Advanced Mission Systems suite. This includes AESA radar, electro-optical targeting, electronic warfare gear, and even the pilot's helmet-mounted display, which lets them see through the aircraft using external cameras. The plane doesn't just feed the pilot data, it becomes their sixth sense, explained a flight systems engineer. Each of these systems has to be wired, shielded, and tested. That means electromagnetic shielding to prevent interference and dozens of miles of internal cabling. Everything must be installed in tight quarters without compromising cooling or stealth. The software behind it all is staggering. Over 8 million lines of code power the F-35. It's updated frequently, which means each jet is built with upgrade ports and diagnostic tools to keep up with evolving threats. Every function, from weapon release to radar jamming, is run through digital simulations before ever being tested in the real world. Only when all systems check green is the jet cleared for its next transformation. Now that it can fly and think, it's time to make it vanish. Stealth coating and paint. You've probably noticed that fighter jets don't shine like sports cars. That's because the final layer isn't just paint. It's a low observable skin, a stealth shield designed to absorb and scatter radar signals. At this stage, the jet enters a climate-controlled finishing bay. Technicians apply a special radar-absorbent material, RAM coating that doesn't just stick, it bonds at the molecular level. This is done in multiple layers with precision thickness. If it's too thin, the jet reflects radar. Too thick, and the panels won't close right, said one technician. Each section is also sealed to prevent gaps. A stray screw head or uneven surface can compromise stealth. That's why every line and rivet is faired or hidden. On top of the RAM comes mission-specific paint. The jet might get low-light gray for maritime ops or desert camo for ground strike. But it's never just for looks. The paint must resist UV radiation, high-speed air friction, and rain erosion at 1,000 km/h. Even here, sensors are used. Every coat is measured and scanned. If it's too thick, it's sanded and reapplied. The result is a surface that doesn't just glide through air, it vanishes into it. Once the jet is cloaked, there's only one thing left to do: put it all together. Final assembly and the mate. In aviation, there's a moment when all the pieces become one. It's called the mate, the moment when the fuselage, wings, cockpit, engine, and tail are permanently joined. It's a ceremony of precision, and once it's done, there's no going back. Technicians use 3D laser tracking systems to align all major components. These machines detect even the smallest misalignment, something a human eye could never catch. It's like building a puzzle where every piece is alive, said one final assembly supervisor. Once aligned, automated torque tools and robotic arms do most of the heavy lifting, literally and figuratively. The connection points are load-bearing, built to withstand not just lift and speed, but sudden G-forces, weapons deployment, and hard landings. After the mate is complete, the jet undergoes the most thorough inspection of its build process. Every seam, bolt, and wire is re-verified. Pressure seals are checked. Fuel tanks are tested for leaks. It's here that the aircraft becomes something new. A complete, airworthy fighter. Now it's more than parts, more than software, more than structure. It's an aircraft capable of rewriting what's possible in the sky. The only thing left to do now is switch it on. Systems check and calibration. With the jet fully assembled, it's time for the first real test, the ground systems check. This is when the fighter wakes up, for the very first time. Technicians connect the onboard computers to external monitors. Systems are booted in stages, starting with basic electronics, then hydraulics, then flight control surfaces. Every flap, rudder, and stabilizer moves under supervision. The landing gear is extended and retracted. The ejection seat system is armed, tested, and then safely disarmed. Inside the cockpit, displays come to life, with diagnostics reading hundreds of variables per second. Then comes the first engine ignition. The jet's main turbine spins up with a deep rumble, slowly growing into a scream. Flames flicker in the afterburner. The exhaust system is monitored for pressure spikes or unusual vibration. That first start is pure adrenaline, one technician smiled. It's the moment it becomes real. Flight software is calibrated, including throttle response, control latency, and autopilot behavior. Everything is benchmarked against simulated test results. If anything's off, it's recalibrated before the aircraft ever sees the runway. Once it clears this phase, the fighter is nearly ready for its biggest moment yet. Its first taste of open sky. The sky trial. Now comes the moment everything has been building toward. The first flight. After months of design, construction, and testing, this machine finally leaves the ground, but it's far from a casual takeoff. This is the most critical phase of the entire production process. Flight testing begins at highly secure military-grade airfields, places like Edwards Air Force Base or Neyes-Patixent River, where some of the world's most skilled test pilots take the controls. For liftoff, the plane undergoes a final round of pre-flight inspections. Software is updated, fuel is calibrated, and all diagnostics must read green. Then, with the push of a button and a final radio check, the afterburner roars and the F-35 rolls down the runway. "You feel it before you hear it," said a ground tech. When that jet lifts off, it's like watching history. During its first flight, the aircraft climbs, banks, hovers, if it's the F-35B, and performs tight maneuvers, all while feeding back terabytes of data to mission control. Sensors log every tremor in the fuselage, every thermal reading, every whisper of vibration in the wings. Engineers are watching in real time, tracking everything from supersonic speed tests to weapons bay functionality, and even stealth performance through infrared cameras. The F-35B, with its vertical takeoff system, performs special hover tests. The exhaust nozzle rotates downward, and the lift fan engages, suspending the aircraft midair before tilting forward and transitioning to flight. Watching an F-35B hover is like seeing a dragon balance on a fingertip, said one flight crew member. Each model performs multiple test flights under different weather conditions and altitudes. Only after it passes every yash test, every maneuver, every safety protocol, is the jet cleared for delivery. But just because it flies doesn't mean its mission is over. In fact, it's just beginning. Global delivery and deployment. Once flight testing is complete, the jet is prepped for its journey to its new home, be it a U.S. carrier group, a NATO air base, or a forward deployed fleet across the world. The first step is personalization. Each aircraft receives its nation's insignia, tail number, and internal system settings. Everything from cockpit language to radio frequencies is adjusted for the end user. If the destination is nearby, the plane may simply be flown there. For overseas customers, it's often disassembled into transportable modules and shipped in specialized containers. At the receiving base, certified teams reassemble and retest the aircraft before the first local flight. It's a global machine, but it feels local the moment it touches down, a logistics officer explained. Pilots don't just jump into the cockpit. They undergo extensive simulator training, followed by real flight hours with instructors. Even seasoned fighter pilots take weeks to fully adapt to the F-35 systems and helmet display. Once trained, the aircraft is deployed into service, onto aircraft carriers, remote airfields, and high-readiness zones. The F-35 is now not just a product, but a core part of global defense networks, ready to connect with other units, relay data, and strike when needed. And as the jet begins its operational life, the cycle at the factory begins again. But what does this cycle look like in the long run? What happens after today's fighters are airborne? Let's look ahead. The future of fighter jet manufacturing. The fighter jet is not just a symbol of power, it's a preview of the future. And the F-35 program has left behind more than blueprints and aircraft. It's changed how the world builds, tests, and thinks about. Military aviation. From additive manufacturing to modular upgrades, jet production is shifting towards smart factories, where parts are 3D printed on demand, and AI tracks every millimeter of construction. Engineers today don't just draw, they simulate. Digital twins of jets are tested in the virtual world before metal ever touches metal. "We used to build, test, then learn," said one aerospace lead. "Now we learn before we even build." The F-35 has taught the industry how to combine stealth with software, power with precision, and international collaboration with local customization. And it's laying the groundwork for what's next. Sixth-generation fighters. These next-gen aircraft are expected to fly faster, think smarter, and act as command hubs for drone swarms. AI co-pilots, hypersonic speeds, and quantum communication systems are no longer science fiction. They're blueprints in development. And behind it all, there's a quiet but powerful push for sustainability. New jet programs focus on lighter materials, energy-efficient engines, and even reducing carbon footprints during manufacturing. So the next time you see a fighter jet cut across the sky, remember, it's not just a weapon. It's the product of decades of human curiosity, global engineering, and tireless innovation. The fighter jet is a machine born from conflict, but perfected through cooperation. "These jets aren't just built, they're crafted," said one veteran line supervisor. "Every one of them carries a little piece of the future. From metal parts to stealth machines, that's how fighter jets are made, layer by layer, test by test." If you found this journey fascinating, let us know with a like and subscribe for more deep dives into how things really work. Thanks for watching, and we'll see you in the next one.